In this video, we'll be studying about the block and tackle system of pulleys. A block and tackle system consists of two sets of pulleys, the upper block and the lower block. The upper block contains the pulleys mounted on a common axle, like in this picture. There are two pulleys that are mounted on common axle, and in this picture there are three pulleys that are mounted on the common axle, and they are fixed to a rigid support. The lower block contains pulleys that are free to move vertically, like in this picture. This is where the pulleys are free to move vertically. The load L is attached to the frame of this lower block, which is referred to as the tackle, also shown in the picture itself. The design of the system ensures that the number of pulleys in the lower block is either equal or one less than the number of pulleys in the upper block. Like we can see here, the number of pulleys are 2, which is equivalent to the number of pulleys in the block. However, in this picture, the number of pulleys in the block are 3, while in the tackle, the number of pulleys are 1 less than that of the block, which is 3 minus 1 as 2. This arrangement allows for significant mechanical advantage as the effort required to lift the load is distributed across multiple strings, reducing the effort needed compared to the weight of the load. Next is the pulley configuration. The number of pulleys in the lower block is either equal to or one less than the number of pulleys in the upper block. We have discussed it before as well. One end of the string is connected to the hook of the block if the number of pulleys in the block is same as that in the tackle, which is this particular image you will refer for this particular scenario. However, one end of the string is connected to the hook of the tackle if the number of pulleys in the tackle is one less than the block. Like in this picture, you can see that one end of the string is connected to the hook of the tackle if the number of pulleys are less than that of the block. Finally, the string passes over the uppermost pulley of the block and effort E is applied at the free end of the string in downward direction. If the tackle is massless and the pulleys are frictionless, then the tension T along the entire length of string is same. Next is the mechanical advantage, velocity ratio and the efficiency. If total number of pulleys in the block and the tackle arrangement be n, then the string has n segments in all and tension in each segment is same. So we have load that will be n times tension and effort will be simply equal to tension, which is T. So mechanical advantage is given by ratio of load to the effort. Since load is nt, effort is T. So we get the mechanical advantage as n. So the mechanical advantage is equal to total number of pulleys and the arrangement acts as a force multiplier. Now let the effort pulls up the free end of the string by distance t, that is Te equals to d. Then each segment of the string supporting the load is shortened by a distance d by n. Hence dl will be equal to d by n, and if we calculate the velocity ratio, which is the ratio of de by dl, we get the value as n. That is, velocity ratio is also equal to n. As for an ideal pulley system, both the mechanical advantage and velocity ratio are equal to n. Hence, efficiency of an ideal block and tackle arrangement is 100%. Practically, on the account of finite masses of pulleys and presence of friction, the real efficiency is always less. So for an actual pulley system, the velocity ratio is n, but mechanical advantage has an actual value of less than n. Let's move on to the next slide. Okay. The effect of weight of pulleys on mechanical advantage, velocity ratio and efficiency. Let the weight of lower movable block of pulleys be W, then in equilibrium condition, total load will be equal to L plus W, that is the weight of each pulley, should be equal to total tension, that is Nt. Now since effort is E, which is equal to tension, so load will be given by L equals to Nt minus W, because we know that L plus W is equal to Nt. So if you want to calculate L, you will take this W on the other side. So L is Nt minus W. And since T can be written as E, so this equation can be modified as Ne minus W. And since mechanical advantage is the ratio of load to the effort, putting the value of load as NE minus W and E remains the same. So what we get from here is, like if we just split these two terms, we get N minus W by E. Also, the velocity ratio still remains the same, that is equal to N, and efficiency can be calculated by dividing the mechanical advantage with the velocity ratio. Since velocity ratio is N and mechanical advantage is N minus W by E, so we get the final value of efficiency as 1 minus W by NE. Since it is something like less than 1, because 1 minus W by NE indicates that something is being subtracted from 1. Hence, efficiency will not be 100%. Efficiency of block and tackle arrangement is reduced due to the weight of lower movable block. For having greater efficiency in actual pulley system, we would like that the lower block of the pulleys should be as light as possible. Moreover, friction of the pulleys should also be minimized by properly lubricating the pulleys. So that was all about it. I hope this topic is clear to you. Thank you.